Hi folks, today's video is about Zkool and GraphQL. So Zkool is a wallet for Zcash, and GraphQL is an API standard. So Zkool GraphQL is an implementation of a Zcash wallet that offers a GraphQL interface. So you have access to the engine of Zkool that powers the mobile wallet and the desktop wallet while having a programmatic interface. So the first part of the video is going to be about getting and building and running Zkool GraphQL. Second one would be a primer for GraphQL in case you're not familiar with that. If you are, you should skip it. And finally, we're going to do we're going to demo some stuff that you can do with Zkool GraphQL. So we're going to do basic wallet operations, like creating an account, getting addresses, sending, receiving funds, sending funds out, and then in the last part, we're going to do something more advanced, which is going to be using the Frost multi-signature wallet. All of that using the web interface. Okay, so first part is getting that running. The whole source code is in open source on GitHub. So you go here, this is the link, and I'm going to create a new directory. Let me make it bigger so that it's easier to read. And clone this stuff, the source code. So we don't have binaries for this because well, it's portable. It's easy. It's written in Rust. It's very portable to a lot of different architectures, and well, it's easier to just build it from source rather than provide 100 different binaries. The only thing you need really is the Rust compiler. On macOS, that means installing Xcode as well, because Rust depends on Xcode. On Windows, it means installing the Visual Studio compiler. Linux is very simple because it just depends on GCC. Anyway, you have the dependencies clearly mentioned here on the Rust lang install website. So you assume that you are run this and you have installed Rust. So now all you need to do is grabbing the source code, clone it from here, and then this is also the whole source code for the front end, the web front end, and the back end. So since we only need the command line utility, we go to the Rust directory and we do the cargo build here. Cargo build will build the library. We want to build a binary, so you do /bin, and it tells us that we need an argument. So the argument is Zkool GraphQL. We also have to activate the feature GraphQL. If you don't, it will say that you need it. Right? Enabling them. Features GraphQL, and also want the release build because it's faster. Okay, let's let it compile. It should take maybe a minute or two to compile. Oh, okay, in the meantime, let's talk about GraphQL. GraphQL is it's kind of like a REST interface in the sense that it's mostly request response. You send a request to the server and it replies with the answer. But it also has a subscription model where you call the server, and then when something happens, the server calls you back. So for that to work, you have to hold a session between client and server so that the server knows how to call you back, to send you messages back. Typically for that, you would hold a WebSocket. So the protocol for GraphQL doesn't stipulate the transport. So it could be HTTP, it could be WebSocket, it could be other stuff. But if you want to have subscriptions, you need a WebSocket or something similar. The HTTP is stateless. So for the most part, we're gonna have only queries and mutations. Queries is when you ask something from the server without changing the state of the application. So for example, if you want to know the current balance, or you want to know the current address, that would be a query. But if you do something that changes the state of the wallet, that would be a mutation. So we have three things, where we have queries, mutations, and we have subscriptions. Let me go to the GraphQL website. And all this stuff is mostly roughly based on JSON. It's invented and used by Facebook. So there's a lot of different libraries, client libraries. You're gonna have typically the client libraries in JavaScript, but they are also for Python and most other languages. What do we have? So it looks like that. The data is described by a schema, so you don't have to do that because the schema is going to be provided by Zkool. And then you make queries like this. Then the result will be something like that. So you can see that the queries, they kind of look like JSON in the sense that they have braces and fields. It's not exactly JSON. It's more like a function call, but the reply is JSON. Okay. So here we are asking the project GraphQL, what is the tagline for it? And it replies, the tagline is a query language for API. So where are we? We're just about to finish. The Zkool GraphQL executable binary embedded interactive GraphQL server. So we are going to be able to work with the tool without a client, right through our web browser. Okay, so that's finished. And in target release, we have this guy here. So I'm gonna copy this guy to somewhere, not this guy. I'm gonna copy target release Zkool GraphQL into something in my path, and rehash so that I know it's in the. All right. So this is it. Now we go back to our demo directory, and we can. Well, we have the source code here, but we don't need that anymore. We just can run it from here then. Zkool GraphQL help. So the help tells you the command line options. You don't have too many of them. The three options you have are where you put the database, the DB path, the URL to the like wallet D server, and the port for the server. You can also put that into a configuration file. So that's why we have this option here. You can either provide these options on the command line with their sensible defaults. DB path would be zkool.db by default. And the light wallet D server will be zkrox by default, and the port is 8000. So if I run it like this without any option, it connects to this guy for the server. It uses zkool.db and it's on port 8000. Alright, so that means that I have the server listening on 8000 localhost. So I can go here and say HTTP localhost 8000, and the endpoint is GraphQL. IQL for interactive QL. For the programmatic stuff, it's GraphQL without the I. So this is the interactive server, which is embedded in the app. Okay, if I open this page, all right, I have a bunch of stuff that I created before. So let me erase the state, clear the storage, and reload. And we can have a quick tour of this stuff. All right, so what do we have here? We have an editor. And editor has multiple tabs. You can create different documents. And here on the right side, there will be the results. You can have variables and headers here at the bottom. We're gonna see what that means. Here you can see the data model, which is pretty convenient. We have queries, mutations, and subscriptions. So the query, these are the methods you can have. So for example, if we want to create a new query, let me erase all this stuff. I can go here, right, in Explorer, and say add new query. This is my new query. I call it accounts because I want to see accounts. Then if I run this guy, nothing much because actually don't create anything. I want to create accounts, so I need to open this guy and say that I want accounts. And from accounts, I want to see their ID, their name, and if you want a seed phrase, you can have a seed phrase here. Then the balance would be nice, and their height. Height is their synchronization height. I can birth out the birth as well, and the height. Okay, let's see all that and run the query. So far I have no accounts. That's why I've empty list. So the first thing we should do now is to create a new account. So to create stuff, it's a mutation since I'm changing the state of my app. So let's go here, down there, and add a new mutation. Let's say mutation. The mutation would be creation. Okay, and then I want to create an account. I want to call this function. The index of the account is 0. Is the seed phrase associated with different account indices. By default, most wallet will use index 0 for a given seed phrase. The key, if I leave it blank, it will give me a new key. It will automatically randomly generate a key. The name would be test account. Why not? Test account. Passphrase, if I want to encrypt this guy, but don't really need that. And I'm not going to use internal. If you can use internal, is you set as true if you want to make it compatible with Zashi. Well, you can make it compatible with Zashi. All right. And at birth, okay, the birth. Well, I don't set the birth will give me the current block height. Then that's my mutation. I can prettify it. Okay, that gives me right, and then I run it creation. They'll give me the one here is the ID of the new account. So if I run this query again, the accounts query, so I'm still recording, right? I should see this accounts, right? So it gives me the seed in one case I want to back it up. Birth is this one, height is this one, balance is 0. Alright, so I have my new account. What I need to know now is the address of this account. So I need a another query for that. And there would be another query. So let's call this query balance address. Or test account, because I'm going to put more stuff into it. Test account. And I want to see, let's see, address per account. ID is account is 1. And I want to see the orchard. Yeah, I want to see the orchard address. They can have this sampling, transparent, or UA. But orchard is the simplest one. Okay, let's run this one then. Test account. All right, so this is my orchard address. And I also want to see the balance. So balance account 1, and I want to see the orchard and the total, which should be the same here at 0. Test account. All right. So yeah, this is my address. This is the balance. So I need to send some funds to this guy. So I'm gonna create a QR code for it. On Facebook. All right, here it is. Give me a second to scan this stuff. So I use Zkool on my phone to send funds to this address. I'm gonna send $1. All right, $1. This error, but it has the transaction ID. Okay, so $1 is on the way. Okay. Since it's on the way, I should see the unconfirmed by account 1, and I should see the transaction ID and the value. Should have something here. Oh, not yet. Okay, well, either this doesn't work or it's not in the main pool yet. That's interesting. Anyway, I have a transaction ID on my phone. That's 0ADE. Let's go to the Zcash Explorer. He's here. Okay. Maybe this one doesn't work. There's a bug here. Alright, let's subscribe though. Let's add a subscription. Okay. And I want to see events for account 1. And I want to see the type, transaction ID, and the height. there's a new block. So this tells me there's a new block. Okay, so it's a new block. Let me remove this guy. Okay, this actually doesn't change anything yet because I haven't synchronized. So let me add a mutation. I call it sync, and then call synchronize. So synchronization, each account has its own synchronization states, and you're able to synchronize any list of accounts independently. So here I only have one account, so I will synchronize this account and then run the sync. Okay, so now this guy here should have some funds. All right, so I have received this guy here. Okay, then what else can I do? Okay, what else do I have here? Create account, delete account. If I want to delete an account, this is DKG is for Multisig. Edit account if you want to change the birth height or the name, and then synchronize with call. Reset if I want to reset the synchronization state. And then the only two ones we haven't seen is pay and new address. Okay, so new address is simple. You call the mutation new address on the ID an account, and then it will create a new set of diversified addresses. So orchard, sampling, and transparent addresses will be generated. A whole new batch of addresses. Well, a new set of addresses. Then pay. Well, pay is when you want to pay someone, right? So let's do a pay. Let's do a pay. So this one it will be also a mutation, and I call it pay. Okay, so then I want to use pay for account number 1, and I want to pay recipients. So recipients is it's either one recipient or it's an array of recipient. So yeah, you can do, this is one, but you can also do array like this. That will work too. And then in this case, need an address, so I will send it to myself. This way I don't have to look on another account. And the amount, let's say 0.001. Okay, and then that's it. Okay, so it says pay from account 1 this recipient, or I can add the memo if I want. Memo test test payment. Okay, and then run it. Pay. All right, so that's the transaction ID. And if I go to this guy, BF4D, I should have in the mempool somewhere. Yeah, this is my transaction. Okay. Okay, so what else do we have? Okay, these are all the mutations. Now let's see the queries. Queries. You can get account details. Oh, I can also get the transaction of this account. Let's see. Test account. Balance by account. Okay, let's see. I want to have transactions by account. Okay, this is what I want. Transactions by account on account 1. Okay, and then I want to see the result. I want to see the fee, the height, the ID, the transaction ID, the time, the value, the notes. I want to see the memo. Pool is which pool? 0 transparent, 1 sapling, 2 orchard. The scope is whether it's an internal or external address. I want to see the address. Then the value. This is the transaction that refers to the address, so that will be the same guy. And the outputs, you can see the address, the memo, and then the spend address, maybe too. Okay, so if I want all of this, that's this query. Right, so transaction by account. Right, we have one account, one transaction. We should have two. No, transaction per account. Well, we only have one because it's the one that we receive funds. And so we received funds from, this is our address. This is the amount we received. There were no outputs beside, because this output is actually this one. And we didn't spend anything. Then that's the fee, and that's the height. That looks about right. So now if I synchronize, I should see a second transaction. Okay, and then let me grab this block and put it down there. And that's test account. All right, so test account. Now we have two. We have ID 2 and ID 1 probably. Yeah. So this is the one before where we received the funds, and this is the one where we move funds to our own self. So we made a self transaction. That's why the value has just decreased by the fees. We just send a portion of the funds to our own wallet or to our own address. So we have two nodes now. One is the 0.001 and this guy is the change. If you also put a pool and you see scope, then you can see that the scope here is 0 because this is the regular output, and this is scope 1 because that's the change, and the addresses are different. This is our internal change address. This is the address we sent out to. So we have two nodes in the same wallet. And the memo says test payment. Okay, that's about right. And then we spend these funds. Okay, we can also see the value that we spent here. Yeah, so we spend this, and these are our outputs. Okay, also put the value output here. Right, so this is a change guy here. So this is detected as an output because it's not directly the address of our wallet. Technically speaking, this may be considered a node. Okay, so that's the payment. We saw how to receive funds. We saw how to send funds, to generate new addresses. Yeah, the data model is you can browse it from here. This tool is very good for that. For example, we can see transaction all the fields are in there. The schema is has introspection. So for example, on a transaction, you can see that it's an array of nodes, and for each node you have this stuff here, and the node has a reference back to the transaction. Outputs and spends, it's the same. Okay, so that's the regular usage. Now if you want to do something more unique, you can also use this to do multi-signatures, forced multi-signatures. So to demonstrate that, what I need is obviously a second wallet, a second person. To do that, what I'm going to do is I'm going to keep this guy as the first one, right? And then we run. Okay, actually leave it like that, so it means running like this. And then also run the same app with another database. So Zkool 2, for example, and on a different port, 8001. Okay, so that gives me a second instance of a wallet. So obviously that should be done by somebody else that's running on a different machine at a different location. But for this demo, I'm just gonna say that these are on the same machine. So I'm connecting here on the port 8001. Right. So we have 8000 and 8001. So same stuff here. I'm gonna delete the state of this browser and then reload. The good thing about this is I can copy queries from one to the other. If I want to see the accounts, I can do this, and yeah, there's no account. I also can create a new account here. It's going to call it test account 2, and also run this. It's account ID 1, but on a different server. Then let me see this stuff. Test account. Let's call it test account 2 in order to avoid confusion. Alright, there no balance, nothing here, right? And I'm going to send also $1 to this guy. Okay, $1 to this guy. Community plan up. Okay, so it's on the way, and so let me prepare the DKG, the distributed key generation. Alright, so I don't need this guy. I'm gonna do is use this as the DKG window. Right. So it's a mutation. It's a mutation that I call it DKG. And what I want is to do the DKG start. DKG start. This one is going to be ID1, and the other guy is going to be ID2. The message account is where I need to get the funds for paying for the messages that are sent between the partners. You need a few cents to do that. So actually I have a regular, you should have a regular account, which luckily I already have, which is account number 1. The name will be Frost. I want 2 participants, and I want to have a 2 out of 2, so threshold is also 2. Okay, so this is the DKG. Okay, right, that gives me my own DKG address. This is not the final DKG, it's just the address I need to send to the other participants to make them aware of each other. On this guy here, alright, so I have created the stuff. What I haven't done is synchronize. So let's create a mutation. Synchronize. And you can 1. Okay. Let's check if we have the funds. Yes, we have some funds. The balance is here. Alright, and it's also account ID 1. Should have it somewhere. Transaction by account ID 1. Okay. So same thing I need to do here, right? I need to make a mutation that starts the DKG. The only difference is that I'm ID number 2, I'm the second participant. I'll still use the message account ID 1. So it's lucky that they have the same ID, but it's ID 1 on a different machine. Also call it Frost. Yeah, why not? And then participant 2, associate 2, same parameters. So let's start this guy. Alright, so that gives me an address here, and this address here is the address of the second participant. You see the Y, and his one is different. So I need to go back here, and then, so this is done. I can comment out. The next step of the DKG is to assign the address of each other. So my address is this one, and if I go to this guy here, comment out this one too. My address, where's my address here? Why? DKG start. It's an address. My ID is 2. Okay, and my address is this guy here. Alright, so this is address of ID 2, which I need to tell to okay, I'm gonna make it like identical on each machine. Alright, so it doesn't hurt if you are setting your own address. So for simplicity, I'm gonna copy the same guy section to the other between all the machines. So this is ID1, ID2. A bit annoying that it's like that, but so what I can do is put it here. Actually, the comma is optional in GraphQL. You can do it this way too. Anyway, so we have 1 and 2. There's an error here because in a given mutation, you cannot have the same function name, but you can alias it. So I can say A1 is this guy and A2 is this guy, just to have different names here. Right, so this is the whole thing that I'm gonna copy, so I'm sure to execute the same thing on these 2 machines. Okay, All right, set this one true, and then this one, okay, set 2. All right, and now we just have to wait. We have to wait for them to do their magic, their handshake and all that crap. So this would take a while. So I'm gonna pause the video and then come back in 10 to 15 minutes, and luckily by then it will be done. Okay, so it has been a few minutes, and I think by now the process is finished, because in the log I can see that we are not in DKG anymore, it's in DKG false, and the last message is actually the shared address. You can see that happening on the console of the first instance, and as well as the second instance, and the address is the same, obviously. So which means that here, if I go back here and I query accounts, I should have 2 accounts. I should have the first one that was my test account, which has a seed phrase, and the second one that it's called Frost but no seed phrase and no balance yet. The same thing on the second node. Right, so these 2 nodes are independent. They have their own database, but they both have the same Frost. Well, not exactly the same Frost, right? Because they also have their private shared secret share. So if you want to back up your seed or your Frost account, you should actually just simply copy the database file. That's the easiest way. Right, so now what I'm going to do is test the multi-signature on this account, and for that I need to send some money to that Frost account. So Frost account here is ID 4. So let's say that I'm going to do it from the second node, just for change. So query Frost address, and then that's address by account with ID account 4, and I want UA. Here UA and Archer is the same, because for a Frost account we don't have sapling or transparent components. If I run this, I should have the same info, right? The UA and the Orchard are the same. So for simplicity, I'm just gonna say it's Orchard. And then send, put the QR code for this. And send some funds to it. I'm gonna send some funds from this account, actually, why not? Already have something here, so I'm gonna pay from account 1 to this guy here, and then this amount should be fine. Alright, so pay. Not enough money here. Okay. Really? I don't have enough for this guy? This transaction required interchange output of 1149 strategies. That's surprising. Let's see why. Balance per account 01. What? This is 2. Okay, synchronize. Oh, okay, I have to synchronize. Hold on. Synchronize account 1. Okay, and then ask about the balance again. There's a fee. 002. I should have enough. Okay, let's go. Okay, how to debug this one. Balance doesn't match. Oh, because okay, this is tricky. Yeah, this is tricky because we are so close to the fee that we have to add an option. Okay, I have to cut this. Alright, so what's happening here is that I'm paying. Okay, this is dust. This is so small that it's dust. But our transaction doesn't want to throw away the dust. So transaction builder enforces that all the inputs and outputs match. And in this case, we would have a change of 1149 satoshis, which is dust. And our builder wants to throw away the dust. Okay, so the thing we can do is increase the amount to put the 1149. 1149. Okay, go. It's pretty rare. It's the first time it happens to me actually. Alright, so now we have this sent to the and the mempool has this guy here, E2. Alright, so what we are doing here is sending some funds to the Frost account, which is like a regular. I'm sorry, microphone was very far. Yeah, so we're sending funds to the Frost account, and we're waiting for it to be received. In the meantime, what I want to do is prepare the payment, the Frost payment. So to do a Frost payment is a bit more complicated than regular payment, because each party, which I heard each the two parties, because we want a 2 out of 2 signature, so both of them have to sign. Each guy will sign the transaction, so they have to receive the unsigned transaction in order to decide whether they want to sign that. And this is done typically out of band, meaning that somebody, either one or two or somebody else actually, can prepare the transaction and inform the guys to sign it. So preparation of the transaction is typically done by one of the participants, but it can be done by anybody that has the viewing key. Once they have prepared the transaction, which doesn't require having any secret component, they will hand it to the signers and say, okay, signers, are you okay with signing this stuff? If you have enough of the signers okaying the transaction, then they would participate in the in this ceremony, and then combine the signature into the final signature. So the process is automated, but the first part where you prepare the transaction is is a bit manual, because it involves sending something out of band, meaning like outside the blockchain. So let's do that. By now we should have the funds. So let me synchronize 1 and 4. And balance 4. Yeah, so I have some funds in the this is a Frost account. All right, so now what I want is to pay, okay, for account number 4, and I'm gonna pay back into account number 1. Why not? So account number 1, the address was what? Well, it should be here. Address number 1 address is this guy. So I'll send it back to this guy. This is the recipient. And the amount is the whole amount of my wallet, so 11149. But also I want to say that the recipient pays the fees. Otherwise I won't have enough funds. So this is basically a max send. I put the entire quantity of the entire balance of my Frost account to send to account number 1, but I have to deduct the fees from that. So I pay per bill. If I do this, it doesn't work, because ID account 1 doesn't. ID account 4 doesn't have a seed phrase. It's a Frost account. So I cannot pay. I need to do it's a query instead, and the query is prepare pay. So this will give me the prepare send. This will give me the not enough, 0.15. Alright, this recipient pays fee doesn't work. I have to do, I deduct 0.015 mosaic required. Alright, let's see. What about this? Is that enough? Oh. What? This sounds like variable is. This is wrong then. Alright. So the payment guide doesn't work here. Alright, so I'll say recipient base fee doesn't work. I need to fix that. And then we also have, okay, this is the amount. Alright, this amount is going to be too much. I need 0.001 more. So we subtract 0.01 from here. Alright, so that's our unsigned transaction. Well, as you see, it's a huge chunk of binary data. And easiest way to keep that is to store it in a JSON variable. So that was this is our unsigned tx, and then I set it as this dude here. Okay. So now, if I want to, what's going on here? Oh, it's not used. So if I want to decode this guy, because if I receive this big chunk of binary, I don't know what I'm signing. So I need something to make sure I'm not signing the wrong guy. Right? So if I decode the PCZT, it's a string. This is how you make a function in GraphQL. So you say that it takes a parameter, which is this guy here. Set that parameter utx, and then I want to see the recipients, and I want to see the fees, the fee. The recipient, I want to see the address and the value I'm paying. Alright, so that's, I don't want to prepare to send anymore. Pretty print. Right, so pay. Alright, so now this big guy here is decoded as being assigned to this address of this amount, and the fee is like that. And this guy here is the change. It's a dummy output. The value is 0. Okay, so that means that I should be okay to sign this. So to sign this, then I need to do the frost signing. So this is a mutation. Frost pay, and mutation frost pay. Okay. What I'm going to call is frost sign on ID account. It's like the account 4. Okay, the coordinator. So the account ID 4 is the account, the frost account. So I'm paying using account 4. The coordinator is the ID of the person who's going to coordinate the stuff. So it doesn't matter who it is, but it has to participate in the ceremony, and everybody has to agree on that person. So I would say ID is 2. It would be the other guy, and message account is the ID of the account that pays. So that was 1, and the PCZT is well, it's the binary guide that we're assigning. So it's UTX. And then I have to pass this guy as a parameter. UTX is a string. Okay. Do the same thing on the other machine. Okay, so let's do that on the first machine. Called frostpay. Alright, so that starts the stuff. And then I do exactly the same thing, but on the second machine. ID account 4, because it's also 4 on the second machine, but it could be something else. The coordinator is also 2. Message account also 1, so it's a coincidence that it's the same funding regular account for paying the messages. And we also need UTX here. I have to copy this guy to this guy here. So normally you do that by email or by whatever signal or whatever to exchange the role unsigned transaction. Okay, now I can run this guy here, first pay, and it's signed true too. Alright, so that only means that the process is started. It doesn't mean that it has been signed. This actually is also going to take a while because of the blockchain messages that have to be sent between these two guys. So these two guys, they need a way to send the unsigned transaction between them, but it doesn't have to be secure because you're supposed to check by using the code PCZT what you're signing, and then the rest is done through messages on the blockchain. All right, and then the same thing should happen, meaning that we wait for the ceremony. So it's going to take like maybe another 10 minutes to do this. Right, we can see it started. All right, so I pause again, and then we come back to see if it's successful in like 5 minutes. Okay, so it has been a few minutes, and I see now that the transaction has been sent, because, well, I say delete frost state in the log, but we can also see that there's a transaction on the blockchain. No, I'm done for. Okay, this is actually coordinator number 1. So there are 2 signers, 1 coordinator and 1 signer. There's always 1 coordinator and multiple signers. So the signers are done before the coordinator. The coordinator is the guy who's going to assemble the final signature and publish the transaction. So the delete for state here is on the signer, on one of the signers, which means that his job is done, but no, the coordinator is not finished. It still says waiting for signature shares. So a bit too early, and we have to wait. We have to wait a little bit longer. So let's come back later. Okay, so this time it's done because the coordinator now is not in frost state anymore, and it has sent this transaction. So if I look for F6E3 on a blockchain, I should have something. F6E3. Well, it's even mine. So that means that if I go here and synchronize my Frost account, and I look for the balance, yes, it's no longer, there's no funds anymore. So the Frost transaction has been done, and so Frost is finished. The Multisig has been completed. I should see some transaction coming to my account number 1. Let's see. Yeah, transaction by account number 1. Account ID 15 F6E3. This is my Frost transaction. It's a test payment. I should have changed the name. This is the value output. Yeah, it's about right to consume the two spans. Okay. Let's see the balance account 1 now. Balance per account. Okay, so account 1 balance. This is account 4 balance. Okay, so account number 1, Orchard 0. Oh, sorry, this should be 1 here. Okay, so I got 17 and account 40. Alright, so let's see on the second one. Mutation, so query balance by account. ID count 1, total, query balances. This is account 1, and what about account 4? B1, B4. Okay, so first account is gone. My funds are 0117 here, 0117, and here 002. Maybe just to also synchronize this guy. Synchronize. No, this was all on the first machine. I have to go here to the second machine. 1 and 4. Okay. And balance per account. B1 and B4. Okay. 002. Nothing on the frost. This one. 0017 and 017. Nothing on the frost. Yeah, should. Okay, at least the frost account has been cleared. Now I still have some money in this case here. I'm gonna take the funds out of my test accounts and send it back to my wallet. But other than that, this is it. This is 1, this is 2, 0, 21, 17, 21. Yeah, it's about the same. Okay, so didn't lose anything. That's good. All right, that's it. Yeah, you can do pretty much anything you want with this. Do transactions, do frost, do DKG, it's all working fine.